want to talk to you in this video about machine language instructions. Remember, the computer doesn't understand anything that we write. It has to be compiled and turned into machine language instructions. What's machine language instructions like? Imagine if I walked into a room and I told us that the only two things we had to communicate with were zeros and ones, and we were going to have to figure out a way to talk to each other using zeros and ones. That's sort of like machine language instructions. Okay, well, that being said, now you know why we write using higher level programming languages like C++. So here's the deal. You saw this picture earlier, main storage and the CPU. Main storage consists of RAM, and I left out RAM. So let's just think of main storage as being RAM. The CPU consists of the control unit and the AL unit. The control unit is the brain of the computer. The AL unit, the arithmetic logic unit, is the workhorse of the computer. The two boxes in the arithmetic logic unit area, the AL unit area, those are data registers, and the one box in the control unit area, that's an instruction register. Okay, so what happens when you and I write a simple program that says something like programming is fun? It's like 4 or 5 lines of code. Well, we name the program sample.cpp. You can see it right up here, sample.cpp. It's 4 or 5 lines of code, pretty simple. The X here represents a compiler. In our world, it's Microsoft Visual Studio. It's the compiler that will take these 4 or 5 lines and turn it into thousands and thousands of machine language instructions represented by this area down here. So 4 or 5 lines of code that we write turns into thousands and thousands of machine language instructions. Sample.cpp first is checked for errors, and if there's no errors it becomes sample.obj, and then sample.obj becomes sample.exe. That's the executable version of the code that we write. So this is really what the computer needs to implement the code that we've written up here. That's X represents a compiler. Okay, what happens then? There's something called machine language instruction cycle. There's 4 simple words: fetch, decode, execute, and store. And every single one of these machine language instructions, every single one goes through the cycle here: fetch, decode, execute, and store. So what's that mean? Okay, let's take the very first machine language instruction right here at the top. The control unit will fetch that first instruction, and it will place the instruction right here in the instruction register. Then the control unit will analyze and decode the instruction. It'll figure out what the instruction wants to have done, and it will get any data that it needs to do it, and it will put the data down here in the data registers, which are located right here. So that's all the decode step. So the control unit will decode or analyze the instruction here and get any data from main storage, place the data here that it's going to actually implement the instruction on. Then the control unit will tell the AL unit to do it, to execute it. Let's suppose in this case it's supposed to add 2 numbers. So the AL unit will then execute the instruction, and then the control unit will then store the result back in main storage someplace. So each one of those machine language instructions, each one of these machine language instructions goes through the machine language instruction cycle: fetch, decode, execute, and store. Again, we write the program in high-level programming language. We name it sample.cpp. It's compiled and it becomes sample.obj and ultimately sample.exe. The sample.exe is thousands and thousands of lines of code, and then each one of those thousands and thousands of lines of code goes through a machine language instruction cycle. The control unit certainly is in charge: fetch, decode, execute, and store. Hope that helps.